Okay, today we're going to be talking about these things called ions. So our learning target is that we are learning about ions and the compounds they form. So first of all, what are ions? Can anybody tell me what an ion is? And if you can tell me what an ion is. Destiny? What is it? Well, so it has to do with the journal. What were we talking about in the journal? Gabriel? Positively and negatively charged atoms. Can you tell me why that's the case? Tell me why that's the case. Why would they have a positive or negative charge? What do you think? Anything on your mind? What were we talking about in the journal? Gaining and losing things. Does anybody remember what things we were talking about? Gabriel says definitely not electrons, which means the answer is electrons. Okay? Electrons have a charge, right? Negative. So what happens is we're talking in the journal about electrons being gained or lost. And if that happens, they're not going to balance out the protons anymore. Okay? And therefore we get a charge. We know that because of differences in electronegativity, certain atoms have a stronger pull on electrons, other elements have a weaker pull. So those ones that have a weaker attraction to the electrons are going to lose them. And the elements that have a stronger pull on electrons are going to gain them. Okay? You got to remember we're talking about negatively charged subatomic particles. So if electrons are gained, then the atom is going to become more negative. And if electrons are lost, then it's going to become less negative, or I should say, more positive. All right? So I'm going to pause here for a second. I'm going to give you the sheet about forming ions. We are going to turn it in for credit, but we're going to do a couple of examples together from it. Okay, so we have this ions worksheet. The first thing we need to do is figure out what kind of ions certain elements are going to form. We should know by now how to find the number of valence electrons. How do we find the number of valence electrons? Periodic table. What do you look for on the periodic table? The number above the column, which we also call those columns groups, correct? Okay, so that's really easy. Just find the element, look at the top of the column, and whatever the number is there, that's how many valence electrons they have. So they have a couple of examples done for you. All right, and this is going to be, I want you to put this in your notes even though the example is done. But so basically, in order to become stable, elements want to have that full outermost energy level. So what they'll do is they'll either gain enough electrons to get a full outermost energy level, which in the majority of cases means they're going to gain enough to get 8, or they're just going to lose all of their outside electrons because that makes the next energy level in the outside and it's full. Easier way to put that is elements will either gain enough electrons to get 8 valence electrons, which I'll just put as VE, or lose all valence electrons. And they're going to do whichever one is easier, which means they're going to do whichever one involves less electrons. So the first example, they give us Li. This is number 3 on the periodic table. Number 3 on the periodic table. So if first thing we're going to do is find the number of valence electrons. They say 1. Let's take a look at why they say 1. Here's Li right over here. If I look at the top of its column, it's in group 1 or group 1A. Okay, so that means it has 1 valence electron, so that makes sense. So number of valence electrons, it has 1. It says electrons gained, electrons lost, and it says ion formed. All right, so according to our rules, what I just told you, it's either going to gain enough to get 8 or lose all of them, which means it could gain, since it already has 1, it could gain 7 more electrons, or it could just lose that 1. So what's going to be easier, gain 7 or just lose 1? Lose 1. Okay, so electrons gained, not going to gain any. It's going to lose 1 electron. Now, okay, so the valence electrons, we look at the group number at the top. So it's in the very first group, so that's group 1A. So that tells us 1 valence electron. Okay, and they'll either gain enough to get 8 or lose all of them. So it has 1 valence electron, so it could either gain 7 to get 8 or it could lose 1. Which is easier? And by when I say which is easier, which one involves less electrons? Go up to 8 or lose all 5. Make sense? So in this case, gain 7 or lose 1. What's easier? Just lose 1. All right, now the ion form. So when we write what the ion is, we're going to write the symbol. And remember what I said, we're dealing with negative charges. Dealing with negative charges. So it's easy to think when it gains something, it becomes positive, or when it loses something, it becomes negative. But remember, since we're dealing with negative charges, it's going to be opposite of what you think. So when it loses an electron, it's losing a negative charge, which means it's actually going to become more positive. If it loses one electron, what is the positive charge going to be? If you're not sure, just look down at your sheet, and it says +1. Now, one thing about this sheet, I don't like the way they write the charges. When I do +1 or -1, I just write the symbol. That's it. So if it's a +1, just plus. Okay? The next example we have is nitrogen. So first of all, find out how many valence electrons nitrogen has. So if we look at our periodic table and we find nitrogen, here it is. It's in group 15. That doesn't make any sense. 5A. Okay? So 5A means that it's going to have 5 valence electrons. When you look at these group numbers, if you ever see the teens, you can either leave off the one in front, or just if it's got the A groups labeled as well, look at the A group. All right. So nitrogen is in group 5A. Which means that it has 5 valence electrons. So either gain enough to get 8 or lose all 5. So it could gain 3 to get 8 or lose 5. What's easier? Gain 3. So it's going to gain 3. It's not going to lose electrons. It's going to gain 3. So it's gaining 3 electrons. It's gaining 3 negative charges. Now, when you write negative charge, there's a little kind of formality with writing charges and other things called oxidation numbers. Technically, what you should do here, well, first of all, if it gains 3 electrons, what is its charge going to be? Negative what? Negative 3, right. Okay? But the way you should write that is the number first and then the minus. So 3 negative. On there, they put -3, didn't they? Okay, but it should be 3 negative. All right, we'll do one more example together. Let's do O. So this one's not done for you on the sheet. Can anybody tell me what group oxygen is in? Okay, so Deviante is telling me that it's in group 6. Does anybody want to dispute this? It doesn't look like it. All right. So if it's in group 6, then how many valence electrons would it have, Troy? If it's in group 6, how many valence electrons would it have? 6. All right? So it's got 6 valence electrons. So Abby, it's either going to gain enough to get 8 or it's going to lose all 6. What is it going to do? Is it going to gain enough to get 8 or is it going to lose all 6? Yep. Gain how many? 2. Very good. So electrons gained 2. We know it's going to gain electrons, not lose them. They either gain enough to make 8 or lose all of them, whatever's easier. So they will, whatever involves less electrons. So it would either gain 2 or lose all 6. It's easier to just involve 2 electrons. Okay, so what is the charge there, Rachel? O2 minus. Does everybody agree? Anybody disagree with that? Okay, I am going to stop right there. Let's talk real quick. We're going to finish the sheet, but so success criteria. What are we trying to do here? Success criteria. What are we trying to do? Anybody want to tell me? Let's see. Nobody wants to tell me? What are you doing here? Okay. Deviante says we are trying to figure out how many electrons an element gains or loses. Okay, and what is that helping us do at the end of that table? Excellent. Thank you, Deviante. Excellent. So I can predict the ion that will be formed by particular elements. Okay, so we're going to spend a little more time working on this, trying to predict the ion that will form over here in this column. We're trying to get to this because that's our success criteria, being able to predict this ion. So if you came into class tomorrow and I said, hey guys, pop quiz, tell me which ions these are going to form, you should all be able to do it. Okay? All right, let's work on this ions worksheet. Save these notes to turn in for points later.